Hello everyone, I hope you all are doing great. This video we will see what is Supra or Baja competition, what all steps are there, what all procedures we need to follow, and then we will see what all stages a team go through this whole competitions, what all challenges we can have there, and all the learnings and all those things. So before that, I just want to mention that whatever I'm going to cover in this video is on the basis of my experience and experience I had with my team. There is nothing theoretical. Let me introduce myself first. So my name is Suraj Singh Rawat, and in 2015, my team named Galaxy Racing, we participated in Supra competition, and we were among the finalists. So yeah, this is a picture I found of my team. So you can see that I'm sitting here. Our team had around 16 members, and I just want to mention one name, Sri Ram. He was one of the core member of our team, and he had a great contribution in the whole success of the project and the team. Some more pictures highlighting the different stages of the whole vehicle we built. The vehicle was loaded in the workshop. We just finished the installation of our engine and some other pictures. Okay, so let's now see procedure of the competitions and overview of the whole life cycle. So yeah, so first thing is you have to register for the competition. It could be a Baja or it could be Supra. So whatever thing I'm going to explain is in journal. There could be a little bit different things in respect to the different competition, but moreover they are similar. So the first thing someone has to do is they have to form a team. So if you're in a college third year or maybe in the beginning of the fourth year, you guys have to form a team, decide a captain, a number of candidate will be mentioned, like how many members could be there in the team. So you have to form a team on the basis of that, and then you have to register your team on the portal. Then there will be a timeline to prepare your documents and all those things for the first round. So what is first round? In the first round, you are not supposed to show any model or any physical component or anything. It's moreover like you have to give a presentation or documentation where you are going to explain them what is your strategy, what's your plan. Good idea if you can create any virtual model and demonstrate it there. So it's more of a round where they actually judge you what's your strategy and what is your initial idea, and the planning. From the first round, there will be a set of teams get shortlisted for the second round. The second round means now you are about to make your hand dirty. So that is the time frame, maybe around 3 months or 4 months, where you're about to design and build the actual vehicle. Now the fourth one, which is the final event. So once you are done with that, then there will be a venue where you will go with your vehicle. You will get some jersey and all those things. You will get a bay section where you load your vehicle, and then what will happen is different panels will come there. They will judge your work on the basis of different parameters. It could be like the crash report, all those things, the testing thing you did in your workshop. There will be some individual tests also, maybe like a brake test or a cornering test or acceleration test. So those things will be there. That will be parallelly go for around 1 or 2 days in the initial one. So all the teams will go through those, and there will be some dedicated points on the basis of that. There could be some disqualifications. So if you are failed in maybe in the brake test, so then you are not eligible for the final racing. So there are some particular tests you are supposed to clear. So once you are done with that, then there will be a final race. The teams who will clear all those tests will go for the final one. In our case, there was around 15 or 20 teams, I remember, and they will actually go on the track and compete amongst each other. And once that is done, there will be a last round, which is the prize distribution. So who is the winner, who is runner up, and who is the winner in different categories. Okay, so that is the overview of the competition. Now let's go and see the functional areas. I call them functional areas because they are the big umbrellas. There will be different other works also which we do, other areas which we have to complete, but moreover they come under these four umbrellas only. So this is the actual time where you will spend the most of your effort and all those things. Now we are going to have a view on this part. Your team should be divided into 4-1. They are the initial responsibility, but they are not the only things one the team will do, because everybody has to contribute and engage with each other, because it's a teamwork. But moreover, you have to assign the people for the different roles. So this roll cage and outer body team will be responsible to design the outer body and create the outer body. So you can see in this picture, this is this wire from, or you can see that this roll cage is the outer body, which is the actual structure, you can say that the bone for the whole vehicle, and all other components, could be engine, it could be a suspension system, braking system, pedal, or anything, even the outer body, the cover will be mounted on this one. So this is the actual one which will be sustaining all the endurance, all the impact and everything. And they have different criteria. You have to design this part very well. We'll discuss it more detail in the further. Okay, so now the second one is the team who will be deciding about the transmission system. So this team will be responsible to actually decide like which kind of engine we can go for, all the assembly related to it, or maybe the vibrations, axle alignment, and all those things. So basically, they are deciding the complete the engine set. So then the third one is the suspension system, where I was primarily involved. So the suspension system design team is basically responsible to design and build the whole suspension system, be it whether it's a arm push rod, then your spring, then the roll center thing, then camber, caster, toe, turning, and all those things, all those calculations, this team will be doing, and they will decide that okay, this is the best fitted suspension system for our vehicle. So there are many things come under this. And then fourth but not the last is the braking system. The members in this team will be working on the deciding what kind of brake we can go for, and then the steering thing also. So when you are deciding the steerings, you should have a whole idea of the spaces you have. So when your wheel, the steering arm is there, so it has to be placed well so that the driver can access it easily, but at the same time it should not be too restricted and the driver is facing a difficulty while coming back. So because in the emergency cases, it should be very easy for a driver to come out of the vehicle. So those things comes there. Then the minimum braking track and all those things, we will explain it later in the presentation. This roll cage or outer body design team, so they are the people who design initially the whole roll cage, the wireframe body, which will be built by the pipes or the rods we will buy, and then bend them and weld them, make the particular angles and all those joints and all those things. So you can see that they have to define this wireframe on the basis of these following. There could be more, but these are the primary ones. So this mounting point, very important parameter. So they have to decide on, basically it's like a communication between the design team and all other remaining teams. So let's say if I'm a suspension system person, so this team will ask me, okay, what kind of suspension you are going to install? Okay, what is the assembly, where this assembly will be mounted, what is the space you need, all those things. So on the basis of my input, I will say, okay, my spring will be mounted at particular angle in the back side of the vehicle. So you can see that here my springs are getting mounted. So there some joint I need, so that I can mount them here. So there will be a eye joint will be mounted on this roll cage, and that will hold the corner of these two springs. So the roll cage team has to create this backside of the vehicle in such a way that they give us a joint here. Okay, and it should be a symmetric one. They should not be unbalanced as well. So the challenge is like this team has to design the roll cage, but they have to minimize the weight. So it's like they have to get the maximum strength, but at the same time they have to optimize the weight. So if you can make a very good mixture between them, like get a good strength at a very lower weight, minimal weight, then your design is a good design. But if you are saying that I have a good strength but your component is very heavy, that means you haven't done a good optimum design. Okay, what I'm saying is like for the steering one, we need something to where this steering rod can be mounted, and at the same time there should not be too many bars. So they have to design in such a way that this chassis is strong enough, it's not getting bent because it's strength, but it's not too bulky. Okay, so and you can see this head bent pipe. So this is for when, let's assume at a time where the competition is going on, your vehicle is at a high speed, because of some imbalancing it got rolled. So it should be well designed and mounted so that it is not getting break. So there is no sharp corner or there is no sharp joint. That is a very critical point where break can happen. Driver should always be safe and your vehicle should smoothly roll and retain its shapes. So that is, all those challenges are there. So little bit of mathematics need to be there, like the curvature should be smooth as much as possible, and this joint should be well designed, the angle should be well designed, so this force is equally getting distributed, or not equally but properly getting distributed. There is no bending happening only the compression or tensile force is getting applied. Those kind of challenges are there. So in our team, we used SolidWorks and a little bit of ANSYS to actually do the FEA and do this design part. But there are other products also like Fusion you can use, and for the surfacing, I think CATIA is one good tool, or 3D Experience. So there are a couple of other. I'm not promoting any of them, but whatever you can access while you are in college is pretty good enough. Bulkiness is one criteria. You have to minimize it as much as possible, but you should not be compromising with your strength. Okay, differential is also a very crucial component. So this rule case team has to build the body in such a way that there's a proper balanced position for the differential, and even once your component is running, they should be well fixed so that vibration is not disturbing the whole vehicle. It's getting equally stabilized, cancel out. Suspension system component, weight distribution, driver position and shifting. Weight distribution is pretty I think pretty understood, that should be constructed in such a way that the weight is getting distributed equally. So the recommended point is the CG should be somewhere in below the driver position. That is what good practice. You can move it a little bit on the basis of what is your design and how you're basically doing it, but moreover it should be somewhere in below the driver seat. So those kind of things is also parameter to be considered. Then aerodynamics, very important for the efficiency of the vehicle. So when your vehicle is completely built and you are trying to boost it, but if it is not good in aerodynamics, you will get a lot of drag, and that drag will kill your efficiency. So you should be considering all those things. Okay, so I think you might get a good idea about it. I will be creating some more videos where I will discuss all these things in much more details, and maybe demonstrate some calculations and some paperwork. So that is about the rule case. Now move and see the engine and transmission system team. So before that, let me tell you, for the competition there will be some specific criteria to decide the engine. You should be a little bit smart to decide an engine where you can get more power with the less weight, or maybe less consumption of the petrol, or maybe higher torque at the lower gear or something like that. So it's all depend upon your type of vehicle. So if let me give you example. So if this vehicle is designed for Supra, so Supra need high speed. So I think for you, torque in the lower gear might not be that much important here, because you're not going to run it at a lower gear. Yeah, for acceleration there is a twist. Like for acceleration you need high torque in the beginning to get a good pickup, but at the high speed, moreover in the higher gears you need a good speed. Okay, but in case of Baja, you will see that they need more torque in the lower, because this vehicle has to go through rough area. They might not require high speed, but they need a good flexibility of the wheel, and all those things. So that is a different criteria. Differential is an engine, both generate a lot of vibrations, and they need a good symmetry while you are assembling them in a vehicle. Okay, so those things are very important. CG positioning, I already told you, CG is very important. So because power transmission team deals with a good ratio of the mass, because the weight, this engine, this differential, axle is a good ratio of the whole vehicle weight. So they have to be very clear and smart to balance those weight and all those things. Vibration, very important, very crucial, and very tricky to handle. And there is actually the what we call the real time problem solving comes when you are in a position where you guys are actually installing the engine. Your whole theoretical calculation will be just gone, and you will just put the weight there, you will start the engine, and engine will start vibrating, and then you have to do all those so we call it in Hindi jugaad. So I will not recommend jugaad, but it's like you have to do the real time mechanical thinking there, like okay, this vibration is going in this angle, I need some rod, or I need something to hold it, so how to weld it, and all those structural calculation. So you guys has to deal with that, and that is a great learning. Insulation, obviously, because this engine will be emitting the heat, and there's exhaust, so that the very hot air coming from the exhaust, so that should be insulated well from the driver. So there is a layer you might seen in the vehicle, that this layer was getting formed only to insulate this whole component from the driver. So the driver, and in between there should be good insulation, and the way of the exhaust should be well designed so that it's not hampering and doing its job smoothly. But at the same time, the angle of the exhaust is very important, because if it is against the air flow, the way the hot air is coming out might feel some drag, and that might hamper the efficiency. But at the same time, you know that we need some back pressure for the exhaust. So those kind of little bit of tweak and learning is there. Pedal design, yes, as I told you, if you're assembling your engine, maybe just take example of my team. We used a bullet engine, which is a two-wheeler engine. So they have a single lever to switch the gear. But if you assume the gear shifter which is there in the four-wheeler, and which we designed for this competition, was for the design of four-wheeler. So how to make this assembly to move that four-wheeler lever movement to our bike engine, which is assembler behind the driver. So those kind of forearm thing you might have learned in your engineering, or you will learn. So those kind of practical applications are there. So you basically design that connection. Okay, that pedal is getting pushed, basically press the two-wheeler engine lever in such a way that it mimic the gear shifting. Okay, so those kind of things are there. So, and the battery and other component, so every engine has different sensor and all those things, so you should be pretty much smart to install it properly on your vehicle. So two-wheeler has this tilting sensor, so once this bullet get tilt, it automatically gets switched off. So that has to be properly managed in your four-wheeler. Another thing also, because we face the challenges when we were in the competition, suddenly the switches which was there in our engine was getting shocked, and the short circuit was happening, and we were not aware what is happening, and we didn't have anybody from the electrical and electronic team. So we found that in the four-wheeler, the way everything is there done with the battery, and the way we had done in the four-wheeler was different. So we try to fix it in the real time. So that was a great achievement, and we were very happy once we were able to overcome that challenge. So now come to the suspension team. This team has to design the whole suspension system, which is combination of your suspension system, like what kind of suspension you are proposing. Maybe you are proposing a arm with push rod, and then you have to think about the mounting, then you have to think about the upright, then you have to think about the camber, caster, all those angles. These are very important angles for the turning, braking, and all of the vehicle. While you're in suspension team, you should be very much aware about a couple of things, like what could be the approximate weight of the vehicle once everything is done and everything is loaded, including your driver also, because that is a weight which will come on your springs. And there is a certain movement you need, or you are expecting on your vehicle, or you're designing your wheel in such a way that it should move by 2 mm, 3 mm, 5 mm, and for the certain weight, this movement should be well transferred to your springs, and your springs should have a particular stiffness that is called free length, and there will be a compressed length. So you have to do a calculation in such a way that that movement is well distributed, so that the spring is optimally compressed. Okay, it should not be compressed too much, otherwise it might break the spring, basically transfer the vibration on the vehicle. So you have to think about it, you have to work on it. And then this upright design. So yeah, so in this picture you can see that there is a component here which is holding the wheel, at the same time allowing the axle to pass through it and basically rotate the wheel. So this is the component which actually hold your wheel, at the same time allow it to rotate, but give a space and position for the steering to push the wheel in such a way that which direction we want to rotate and all those things. So you can see that these are the members which are holding this whole assembly with the chassis, but at the same time there is one component here which is basically transferring the vertical movement, or the vibration, so called in the simple word, to the springs. And this component is also very important because it rationalizes the movement of this wheel to the movement of the spring. So if your wheel is moving by 5 mm, maybe you want the spring to be compressed by 1 mm, so you have to do a 5:1 ratio or something like that. So those things are there, and you might be able to see one rod which is going through this one. Maybe I'm not able to show it here. This upright structure is in this way. These two are the members which are actually holding this upright with the chassis, but this is the member which is getting pushed by a rod. So if it is getting pushed outside, this wheel will move in this way. Maybe in the simple word, it will move here. Getting pulled, then this will move in this direction. This is the actually, so you're turning right or you're turning left. So this is how design works. I will create video in my channel where we'll explain this thing in much detail. Okay, so these are the things. Then rolling center, a very important component. This is the point about which the whole suspension system also moves. Let's go with this picture. So if this is the front of it and your suspension system moving in this way, so how this roll center plays role is like, this is the front, you are looking at your vehicle, and this is the wheel. So if your wheel is going up or down, so this is actually a hypothetical point about which the suspension system is rotating, in the simple word. So the actual idea is to keep it as much as near to the ground, but we can't go ideally with the ground, because the arm positioning become little critical, and that actually hamper the movement of the wheel. What I'm trying to say is, if you go too much near of the ground, then these arms of the suspension might tilt in this way to make a cross section at this point, and that might resist the movement of your wheel in upper direction, because your arms are already too much bended, so there is no space here for the movement of this rod. So that is the actual compromise we do to hold it here. So a couple of other things are like, the wheelbase, track weight, ground clearance, and all those things are the points which the suspension team has to decide. Okay, I think that is a pretty much a good overview of the suspension system. Now let's move ahead and see the fourth one, which is braking systems. A point I want to mention here is like practical and theoretical, they both have different worlds. So when we are in engineering, we design things theoretically on the basis of equations and all those things. But if you see industry, you'll find that when the industry is doing any kind of design, they do a parallel check of the availability in the market. So you should be pretty much clear about the manufacturing processes which are available nearby you, the material which are available nearby you, your cost, efficiency. So what I'm saying is, like, let's say you design a component which is very efficient by engineering and very finished one, but it's a waste if you are not able to build it or you're not able to manufacture it. So what is the hurdle? The hurdle is where you are living and what is your reach and the market, what all kind of machining processes are available. So if you don't have a laser cutting machine available in your nearby you, then if you are doing a component, a sheet where you are doing a sharp cornering and all those things, you're saying that we need this component, I think you're making yourself fool, because you're not going to manufacture the component. So what you need to do is like thinking about the processes available and then do your designing on the basis of that. Parallelly, we do is like we go for some standard available component in the market, let's say the steering system. So design and manufacture the whole steering is not a efficient way. So what you should be doing is like, or what we did is like we went for a efficient steering system and we try to manage it with our vehicle and did the designing of the vehicle in such a way that we are going to afford that steering, and it saved a lot of our time, a lot of the efficiency efforts also, and even give us some advantage of that particular component. And while you are doing this thing, braking team has to guide the chassis team to design this initial component. So here is like this whole assembly need to be installed in front of the driver. So there in the front there are three pedals and you need some space for the driver to come out of the vehicle. So yeah, there is one particular test which we had in the Supra was they calculate the time how fast your driver can jump inside the vehicle, plug in or all the safety belts and all those things, and then remove them and come out of it. So it will be only possible for the driver to come fast if the space is good there, all the components are well arranged. So no, so it's not facing a hurdle, the wheel is close but not too much close, the pedals are well balanced, they are not hindering with foot of the driver and all those things. So this assembly has to be assembled in front of the vehicle. So you have to think about it and communicate with the roll cage team how we decide the braking system. So you should be aware that how much the braking track is allowed. So like once you completely apply the brakes, how far the vehicle is allowed to move till the time it gets zero velocity. So it should not be zero ideally, because if it is zero then it's very dangerous for the driver, and ideally the no component should stop completely zero at once. There should be some space for the vehicle to travel before it gets to zero speed. Weight distribution during braking and acceleration. When you apply the brake, there will be some weight getting distributed from back to the front. From the back, there will be a momentum you will feel, which will be traveling to a front. And at the acceleration time, there will be a weight transfer from the front to the back. So while you are braking, the front wheels and front calipers should consider all those transfer things. So it is somewhere 30-70, if I'm not wrong, 60-40 or 30-70. So when you apply a brake, there will be mass transfer or weight transfer to the front. So the front suspension system and braking system should be designed in such a way. Even the angle of the steering, because the driver is holding the steering. So once the mass is transferring, the driver should have a good grip. At the same time, his arms should be straight enough to hold the momentum. And while you are accelerating, the back component should be well designed, the vibration and all those things. Okay, the steering and other component mounting and all those things I already mentioned, that the body should be designed in such a way that all the components are getting well mounted and spacious with respect to each other. So space is good enough there. but it should not be two spaces, otherwise the size of the vehicle will increase. So I think those are some of the criteria you should be considering, and these are the things you will learn as well as face during your participation. Now come to the challenges I want to mention here, and they are the good challenges. First point is availability of your design and need of component. So what we faced and what you guys will also face is like, what was the design in your mind, how you design it, and at the same time there will be few things which are not available in the market. So you will find that resistance there, like, oh, I've designed this thing, we want this kind of joint bearing, maybe arm, or this kind of operation, this kind of bending, this kind of grinder. So those are not available there. So available components will be a difficult thing. So as a mechanical engineer or design engineer, you should be considering about those things. Consideration of the standard part on the market. So you should be considering the standard component which are available in the market. You should not be always, inside your own world and just thinking about the good ideas and all those. Your idea should be well validated with the resources which are there. Any industry which, when they do the designing things, they parallelly do the practicality check also. Management and communication within the teammates, yeah, this is one great learning. One of the biggest challenges, like a communication between teammates, how to motivate them, keep the momentum of your team. When you go with this kind of competition, it's not a one night success. Every day you guys will be creating component, doing things together, facing the failures, because it's not like you do design something, go there in your workshop, do something, and you get a final component. No, more 90% of time things will break. Even till the last day of the competition, you will be doing something. This is what happens. You, at the last day also, you will be doing some welding, some grinding, something like that. So this is what the practical thing is. Practical world challenges during this whole thing. When you will be there, theoretical thing will not help you anymore. Anytime there will be a little bit of theoretical knowledge which will be helpful for you, but the practical ground reality is different. When you are there, you are holding the pipes, you are bending it, think about, okay, this is the angle, this is the force, and this is the torque, and this should bend by this angle. No, the practical thing is like how you're holding it, where you are plugged it out, how, what kind of material force you're applying, and all those, the tools available. Maybe you don't have a tool in your workshop, so you have to manage doing this kind of bend using some other tools. So those kind of things are there. Repetitive process, yes, things will break, you have to do it again and again, so you're not supposed to lose your momentum or your motivation. So the small success will be only key to move ahead. Now come to the outcome and learning. Whether we succeed or fail doesn't matter, it's only like what we learn through whole journey. Team collaboration is one thing which you will learn if you go through this competition successfully, or this kind of competition where you are working with a team on some common agenda. So team collaboration is something, one skill you will learn, like how to deal with the team members, how to let go your short success for somebody else, how to help other people to succeed and achieve their success, how to keep other people motivated, at the same time get a support from others, talk with other people in their languages. When you go for getting your component manufactured to the local area, there the people who are there in the workshop might not understand all the engineering concept, all the languages, so you have to talk with them in their languages. So those kind of learnings are there, and that is the actual real world. Real time problem solving, yes, the earthing thing I mentioned, that was a time where we were in between the competition and everything was failing, and we didn't have anybody else to approach. So the only thing was like to brainstorm within the team, think about it, do everything whatever we can do, and the ultimate goal which was there in the mind is like to complete this thing anyhow, and we did it. Leadership quality, I told you, like help other people, help them to lead, and all those things. Sacrifice your success for somebody else also, because ultimately it's team success. So if somebody else is having some idea, you have some other idea, but you want the team success, maybe the other people idea is more important, so you will say that, okay, let me go with your thing because your thing is much more beneficial for us in the long term. So you will work with them or collaborate. Feel real happiness is like do small thing, and it's not like you think about the whole vehicle and you say that, okay, once the whole vehicle is done, then only I will be happy. No, that thing will not come. It's a time like you bend something, you do a welding, you say, oh, we are finally having this joint, and you will actually enjoy it, because for the 10 nights you are working on it and finally you got that bend. Technical knowledge about the process and materials, yeah, because actually you will work with material, you will work with components, you will work with all those, you will feel the vibration by your hand, you will do all those engineering concept things and everything. So you will learn about it, like how much heat we need to give before hammering some component and all those things. Endurance, yes, you're not supposed to get afraid of the failure, you have to sustain it, keep calm, work on it, do physical work, do mental work, everything. And the ultimate thing which I learned is hard work is the key success. It's not like a donkey work, I'm saying, but it's more of like you have a dedication and you're saying that how many times I get filled doesn't matter. You want to complete. So that is the ultimate thing. Work on your ideas, do your best. More than the list and all those things and the name, the learning I had from this project was one of the remarkable learning of my life, and I'm following some of the things which I learned from there in my professional life as well. Okay, so with this I thank all of you, and I hope you guys might got some idea about the whole process and some of my experiences. If you want to learn more, if you have some questions, please put them in the comment section. Do share this thing with your friends and people who are in automobile mechanical students and all. Yeah, with this I thank all of you and see you in the next video. Thank you.